Remove the axle shaft and the sun gear attached to it. Remove the bolts holding the planet carrier to the wheel assembly. Using a crane and a lifting device of choice, safely remove the planet carrier. Remove the 10 bolts holding the retainer cap and any shims that come with it. Safely rig up the ring gear. In this instance, we used a bolt to help safely distribute the weight and rig it up evenly. Using a crane and a lifting device, remove the ring gear assembly. Safely remove the wheel assembly from the final drive by, again, using a crane and lifting devices. In the final drive, the dual cone seal prevents wheel seal leaks. It also prevents outside debris from entering either the axle or the wheel end. The use of the dual cone seal can also be used to absorb the differences of alignment between the axle end and the wheel end. The use of the rubber toric or load ring also acts as a spring, which keeps the seal ring faces compressed and sealing. The dual cone seal is a metal-to-metal seal. The dual cone seal is comprised of 2 seal rings and 2 rubber toric or load rings. The sealing action of the dual cone seal happens at the seal ring's face. The shiny part of the seal ring face is where the sealing occurs. If the sealing surface is beyond the halfway point of the seal ring face, into the dull area, the seal has worn and it may be prone to leaking. The rubber toric ring will be installed in this channel and create a seal between itself and the seal ring, and also itself and the housing. If any sealing aspect of the dual cone seal is compromised, leaks can occur. Inspect all components of the dual cone seal for any cracks, deformations, rips or tears, scratches, fading, contamination, or any other impairment that may compromise the sealing ability of the dual cone seal. This includes the seal ring face, the rubber toric ring, and also the dual cone seal housing. To install the dual cone seal, use the dual cone seal installation tool. If not using the installation tool, the dual cone seal may not seal correctly and may be prone to leakage. The dual cone seal installation tool is based on the seal ramp angle. Use the appropriate installation tool. Install the rubber toric ring around the seal ring and ensure that there are no twists or kinks in the rubber toric. To utilize the installation tool, set up the lip under the seal ring face, compress the tool, and tighten the wing nut. Before installing the seal into the housing, clean all mating surfaces thoroughly and make sure there are no damages to any of the components. When installing the seal into the housing, use something that promotes lubricity but does not leave an oily film. For example, isopropyl alcohol. Use of a rubber mallet or soft hammer is permitted. Try not to aim for where the two halves meet, as damage to the tool can occur. Using a measuring tool of choice, measure the assembled height. The assembled height is the distance between the seal ring's face and the top of the housing retaining lip. Measure in at least 4 places that are 90 degrees apart from each other. The measurement should be within 1 mm or 0.04 inches of each other. If adjustments are needed, do not push on the seal ring. Instead, use the installation tool. After installing the dual cone seals to both the wheel assembly and the axle assembly, carefully reinstall the wheel assembly to the axle assembly. After installing the wheel assembly, carefully reinstall the ring gear into the wheel assembly. Place the retainer plate on a flat surface. Using a measuring device of choice, measure the thickness of the retainer plate at each of the 3 small holes. Average the measurement and record the result. Install the retainer plate without the shims. Apply oil on the threads of 3 bolts and install the bolts onto the retainer plate. These 3 bolts must be separated by 120 degrees. Tighten these 3 bolts to a torque of 85 plus or minus 10 pound-feet. Rotate the wheel 360 degrees. Check the bolts, and if necessary, tighten them again. Loosen the bolts and rotate the wheel 360 degrees to unload the bearing. Tighten these bolts again to a torque of 15 plus or minus 5 pound-feet. Rotate the wheel 360 degrees. Check the bolts and, if necessary, tighten them again. Using a measuring device of choice, measure the depth through the 3 small holes of the retainer plate, average the measurement, and record the result. Subtract the average thickness of the retainer plate from the average depth. The result is the gap between the spindle and the retainer plate. This is the thickness of shims required. Using a measuring tool of choice, measure the shim pack. The thickness of the shim pack must be within 0.025 millimeters or 0.001 inches of the required thickness. Remove the bolts in the retainer plate and install the shims required. Install the retainer plate and the bolts. Tighten the bolts to a torque of 92 plus or minus 15 pound-feet plus an additional 120 degrees plus or minus 10 degrees. This final drive works on the premise of planetary gear sets. The axle end is bolted to the axle housing and is held stationary. When the wheel end is installed, the ring gear is fitted into the wheel end and splined to the axle end. As a result, the ring gear will be held stationary. The axle shaft is driven by the differential, and the sun gear is splined to the axle shaft. As a result, the sun gear is the driving member of the planetary gear set. The planet carrier is bolted to the wheel assembly. Due to the fact that planetary gear sets need a driving, driven, and held member, since the sun is the driving, the ring is held, therefore the driven member must be the planet carrier. As a result, this will lead to a maximum speed reduction but a maximum torque increase. In this instance, the sun gear has 17 teeth and the ring gear has 64 teeth. Therefore, the planet carrier will have 81 teeth. Since the sun gear is driving, the ring gear held stationary, and the planet carrier is driving, that makes the final drive ratio 4.765 to 1. This means that it will take the sun gear 4.765 revolutions to get 1 revolution out of the planet carrier.